ಅದರಲ್ಲಿ ಲೆಂತಿ ಕ್ವೆಶನ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಸರ್ ಸ್ವಲ್ಪ ಆಲ್ಮೋಸ್ಟ್ ಟೈಪ್ಡ್ ಇರಬೇಕು. ಯಾವುದೋ ಒಂದು ಟಿಕ್ ಮಾಡೋ ಮಾತ್ರ ನಾವು ಮಾಡ್ಕೋಬೇಕು. ಕಷ್ಟ.
ಸರ್ ಜಾಯ್ನ್ ಆಗಿ ನೋಡಿ, ಬರ್ತಿದ್ಯಾ ಸುರೇಶ್ ಸರ್? ಲಿಂಕ್ ಕಳಿಸಿದ್ದೀನಿ ನೋಡಿ. ಹಾಂ ಸರ್ ಜಾಯ್ನ್ ಆಗಿ ನೋಡಿ, ಬರ್ತಿದ್ಯಾ ಸುರೇಶ್ ಸರ್? ಲಿಂಕ್ ಕಳಿಸಿದ್ದೀನಿ ನೋಡಿ. ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ, ಸ್ಟ್ರೀಮಿಂಗು ಆಗ್ತಿದೆ. ಅನ್ಲಿಸ್ಟೆಡು ಕುತ್ಕೊಳ್ಳಿ. ಇವಾಗ ನಮಗೆ ಇದು ಸರ್ ಬನ್ನಿ.
Okay, welcome to the physics class, dear students. Welcome you all for the online coaching classes. So that we are starting with the KCET, NEET and JEE online coaching classes, dear students. So that I am going with the physics. So today we are just going to discuss with the electric charges and fields online classes. So dear students, here it was the first bit. The first bit goes in this way. A charge Q is divided into two parts, Q1 and Q minus Q1. So what is the ratio of Q by Q1 so that the force between the two parts placed at a given distance apart is maximum? So here it means I am just dividing that the charge Q into two parts, that is Q1 and Q2. Whereas here they said that the charge Q1 is equal to Q. See, I'm just going to say that the charge Q1 is equal to Q and the charge Q2 is equal to Q minus Q1. And in the question, they given that, you can observe the pointer that I'm showing you. It was placed at a given distance apart is maximum, right? So it means the force is maximum. Now I am using the formula for force, my dear students. So that the force is equal to 1 by 4 pi epsilon naught, which can be written as K into, you know that, Q1 Q2 divided by R square. Here the distance, they have not mentioned anything in the question, but now I am just going to substitute Q1 and Q2. Here what will happen is equal to K. What is Q1? It is Q. What is Q2? It is Q minus Q1 all divided by R square. But in the question they said at the last line, you can observe that the two parts placed at a given distance apart is maximum. So it means the maximum indicates that if the force is maximum, it indicates that the charge Q1 and the charge Q2 both are same. So that I can write Q1 is Q, which is equal to Q minus Q1. I want to calculate the value of Q by Q1, right? So here Q is equal to Q minus Q1 we have. So if I am just going to shift the terms, what I will get? Definitely I can get the value of Q1 which is equal to that of the value of two parts of Q, that is what 1 by 2 times of Q. That is what easily I can say the ratio of Q by Q1 is equal to 2 by 1. So what was the question? We should calculate the ratio of Q is to Q1, that is what Q is to Q1 is equal to 2 is to 1. So my dear students, the option B is the right answer, that is what 2 is to 1 is the correct answer. Now let us move with the second question. Here the three charges plus Q are placed at the corners of an equilateral triangle. At the circumcenter O, the electric field strength is. So here it was a question. Then you can observe the diagram which was given on the screen. So here they given the equilateral triangle, whereas as they said that at the equilateral triangle, is having the 3 corners, whereas at the 3 corners we are going to place the charge Q. Here we have the 3 charges placed at the 3 corners of equilateral triangle. So then what we should calculate? We should calculate the electric field strength at the circumcenter, that is at this point O. You can observe that carefully, that due to this plus charge, the electric field direction is towards this direction, whereas according to that, the direction of electric field produced by the positive charge, here you can observe that due to the charge which is present at the C, so that the electric field direction is towards this way. Similarly, due to the charge which is placed at A, the electric field direction is towards the downward direction. It means here the electric field is in equilibrium, so I can say that the total electric field at the circumcenter is 0. It means that the option A is the right answer. Now let us move with the next question. You can observe that the question was like this, my dear students. Here you can observe the 2 small spheres carry charge of plus 3 nanocoulomb and minus 12 nanocoulomb respectively. The charges are distance d apart. The force they exert on one another is F1. The spheres are made to touch one another and them separated to distance d apart again. The force they exert on one another is F2. Then the ratio of their forces is. So this was a question they given. So first I am going to consider the 2 charges which are exactly placed. So I am going to give the name for those 2 charges. My dear students, the first charge they given in the question, which is equal to plus 3 nanocoulomb, and another one is minus 12 nanocoulomb. See here, one charge is positive charge and another one is negative charge. And they said that both are separated by a distance of d apart. So I am just going to write the distance as d. But in the question, you can observe that here the charges are at a distance. You can observe the pointer carefully, that I am just showing you. So that distance d apart. After that, what exactly the thing is that the force they exert on one another is F1. No issues here. But the spheres are made to touch one another. See, when these 2 spheres are exactly away at a distance of d, the force exerted is F1. So how to write the force? Again, the force can be written as 1 by 4 pi epsilon naught into Q1 Q2 by R square. Q1 is 3 nanocoulomb, and see, I am just writing it as 3, and I am not just substituting nano. Why? Because in the force F2 also we are going to cancel that nano, and here the next thing is minus 12 nanocoulomb all divided by d square, right? This is a force F1. We can consider this as equation number 1. Similarly, here in the question they said that they touch each other, they touch one another. So that touch one another, it means we have the two charges, right? That is minus 12 and plus 3. So when they touch each other, so minus 12 plus 3, it becomes equal to 9, and then again they separate by a distance of d, which was given in the question. It means minus 12 plus 3 becomes 9 coulomb. So if again they are going to separate with each other, then what happens? So that the 2 charges again they are going to separate each other with a distance d, but the total value of the 2 charges is that is what, 9 coulomb. First one is 4.5 nanocoulomb and the second one is 4.5 nanocoulomb. Then here the force which was acting here is F2, so that the F2 is equal to 1 by 4 pi epsilon naught into Q1 is 4.5, Q2 is 4.5 divided by the distance is d square. Take it as equation number 2. So that we have the 2 forces F1 and F2, my dear students. Now I am just dividing these 2 equations. I am just dividing these 2 things. So I am just going to substitute the magnitude. So no need to write minus here. So just you can write the plus and you can do it. So I am just calculating the force. So to calculate that, just divide it once. So I am just dividing equation 1 by equation 2. It means force F1 by F2, which is equal to, you can observe that K by d square is present in the F1 as well as k by d square is present in the F2. So that the k by d square cancel with each other. Remaining is 3 into 12 divided by, here we have 4.5 into 4.5. Dear students, 4.5 into 4.5 was there. It can be written as 45 by 10 into 45 by 10. So that if you just do the calculation, I will get the ratio 16 by 9. So that the option D becomes the right answer. That is F1 is to F2. That is what the ratio of F1 is to F2 is equal to 16 is to 9. So dear students, finally we calculated that the value of the ratio of F1 is to F2 is equal to 16 is to 9. This is about this third question. Now let us move at the question number 4. Dear students, in the question number 4, you can observe it very carefully. So you can even observe it very carefully that they given that a charge is placed at a center of a cube of side A. So first, here they given the question, right? That is what the charge Q is placed. That is what the charge Q is placed at the center of cube. So they given that we have placed it at the center of cube. So what I am just doing here, I am just going to write a cube now, my dear students. So here I am just going to write a cube. So here I am just going to write a cube first. So whereas at the exact center of this cube, I am going to place a charge with Q. So the magnitude of the charge is Q. The Q is placed exactly at the center. Then the question is the electric flux through any one face of the cube. What we should calculate? The electric flux through any face of a cube. So dear students, you should be very careful that you know the formula for the electric flux is equal to Q by epsilon naught. But here for the given cube, how many faces we have? We have 6 faces. Then for one face, how much will be the electric flux? For one face, the electric flux may be equal to 1 by 6 times that of the Q by epsilon naught. So that, my dear students, for any face, the flux for this cube for a charge which is exactly at the center of the cube is equal to Q by 6 epsilon naught. That is what you can observe that on the screen. The option C gives you the correct answer. That is what? Q divided by 6 epsilon naught. Now even let us move with the next question. That is what? The question number 5. You can observe the question number 5. Here they said we have the metal sphere, right? We have the metal sphere A of radius capital R as a charge plus Q on it. The field at a point B outside the sphere is E. Now another sphere of radius 2R having a charge minus 2 is placed at point B. The total field at a point midway between A and B due to both sphere is. So ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? They exactly given us that we have the 2 spheres ಅಂತ ಹೇಳಿದ್ದಾರೆ. So let us write the 2 spheres first. I am going to write one sphere and again let us write another one sphere. See, I am just writing another one sphere with a bigger circle. So why? Because here they said in the question, one sphere is with a radius capital R and another sphere with a radius of 2R. So this is a sphere with R radius and this is the sphere with the radius 2R. Now here at this question, in this question, they said the field at a point B outside the sphere is E. So here the sphere with a radius R is considered as a sphere A and the sphere with a radius 2R is considered as the sphere B. So whereas the electric field is exactly acting outwards. You know that, my dear students. Here they said A is a sphere of radius R with a charge Q which was given in the question. The charge which is present inside the sphere is Q and the charge which is present inside this the B is again minus 2Q. Dear students, then what is the electric field which is acting here? If I just consider exactly at a midpoint, I am just going to consider a point P. The field due to the sphere A is E1 and the field due to the sphere B is E2. so that we have the two fields A1 and A2. And dear students, know that we have the formula for E, which can be written as K into Q divided by X square, Q divided by R square, or Q divided by X square. Here assume that these two spheres are separated by a distance of X. So I'm just going to take it as X. Then what is a distance between the sphere A and the point P? That is X by 2. Similarly, the distance between the point P and this is again considered as X by 2. Then I just written the formula, and also we just analyzed the given problem, given bit with an example, with just by writing out the picture, right? That is what, by writing out the diagram. Now let us calculate the total electric field. So dear students, what is the total electric field? So the total electric field E is equal to E1 plus E2. Now let us substitute the values. E is equal to K into. What is E1? E1 is the electric field due to the sphere A of charge Q and radius R. Then now I am just going to write the charge is Q divided by, what is the distance? Distance is X by 2 whole square. Why? Because here I already shown you that, the distance between this point P and A is X by 2 plus, what is E2? K into. Here I am just writing the value of the charge is minus 2Q divided by, here again the distance I am just writing, here the distance again which comes is equal to X by 2 whole square. Now, here my dear students, E is equal to K into, see, here X by 2 is there, that is what, X square by 2 square, it means X square by 4. 4 is in the denominator of a denominator which comes to the numerator, so I can write it as 4Q divided by X square plus, so again I am just going to place K as it is, X square by 4 we have. If I just move towards the numerator, it becomes minus 8Q divided by X square. Here what are all the common terms we have? We have the common terms are K divided by X square into 4Q minus 8Q. So my dear students, 4Q minus 8Q, which is equal to K divided by X square into minus 4Q we have. Right. So finally we got, my dear students, so what I just did, here I just written it as 4Q, but I did a mistake. So we should not consider the minus symbol here. We should consider only the magnitude, my dear students. We should not consider this minus. So that 4Q plus 8Q becomes 12Q, right? 4 plus 8 becomes magnitude matra tagobeku. We should not consider the minus. So it becomes 12Q. What's the total value of E now? E is equal to K into 12Q divided by X square. I am going to take 12 outside, right? So 12 into, so KQ divided by X square. Whereas just now what I calculated, it is E total is equal to E1 plus E2. Then what is my complete value? My complete value is equal to 12 into, what is KQ by X square? So what is this KQ by X square? Here it is, that is E. So 12E, so that the total E is equal to 12 times of E, that is option C gives you the right answer. So here it is option C which gives you the right answer. Now let us move with the next bit, my dear students. Here we have a question which is exactly related with that is dipole. So you might have derived the expression for the dipole in case of axis and also equatorial plane. So ಇಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, they given an equilateral triangle ABC of side 1 meter. So I'm just going to write. So simultaneously reading a bit, and also I'm just going to write the things also here. So the equilateral triangle ABC with sides 1 meter. So I just represented a side as 1 meter, and they given that at point B they placed plus 1 microcoulomb and at point B they placed minus 1 microcoulomb respectively. And now the electric field at point A. We should calculate the electric field at point A. Dear students, consider that this as a charge plus Q, right? And this as a charge minus Q. Because the charge plus Q is plus 1 microcoulomb and the charge minus q is minus 1 microcoulomb. According to this, the direction of electric field lines which comes by the positive and the negative charge, with that idea I am just showing you here. Due to this plus 1 microcoulomb, the direction of electric field is outwards at point A. So take it as E1 is the electric field. And here, due to this point charge minus 1 microcoulomb, the electric field line is exactly towards the charge, that is exactly towards the charge from point A, that is 2. Dear students, now even you can observe that this is an equilateral triangle, then the angle is 60 degree each. So that 60 degree I am just going to write here. So all the angle is equal to 60 degree. All the angles are equal to 60 degree. Right. Now, we should calculate the effective electric field at point A, right? So the resultant electric field can be written in this way, right? So now, if this one is 60 degree, you know that from the mathematics, sum of that is what interior angle is equal to the exterior angle, so that this angle becomes equal to 120 degree, whereas this is a resultant electric field E. Now we should calculate the value of capital E. How to calculate this value of capital E, my dear students? See, you know that by observing this, you can come to an conclusion that here we should want to calculate the here we should calculate the electric field at an axis. Even also we should calculate the electric field at equatorial point. Dear students, it's a very easy thing to calculate, but here dipole is there and already A is also present. There we have deduced already that E is resolved into two components, E1 and E2, and we can calculate it very easily. Now I am just doing it here, so you can observe that E is equal to, so I am just going to substitute E is equal to, so you know the formula electric field, formula E is equal to K into Q divided by R square, right, which is equal to. Dear students, so while doing this thing, you should be very careful that K is 9 into 10 power 9 into, what is the value of 1 by 4 pi epsilon naught, that is 9 into 10 to the power of 9, and what is Q? 1 microcoulomb, that is 1 into 10 to the power of minus 6, all divided by R square is 1 square. See, now the value of the electric field at point A is equal to, see, 9, I am just going to write 9 as it is, 1 square is 1, no problem, into 10 power 9 into 10 power minus 6. 9 minus 6 gives you 3, that is what, 10 to the power of 3. Dear students, see, it is Newton per coulomb. So my dear students, see, it is very easy to calculate. We just substituted the values in the formula and we calculated the value. That is what, 9 into 10 to the power of Newton per coulomb, 10 power 3 Newton per coulomb. Then whether it is parallel to AB, parallel to AC or parallel to BC, for that reason I just did this diagram. I just written this diagram here. You can observe that the line E that what I written here is parallel to BC. So I can say that the electric field E, which is equal to 9 into 10 power 3 Newton per coulomb, is parallel to the line BC. So which option is right here? Then the option B, which gives you 9 into 10 to the power of 3 Newton per coulomb parallel to BC, is the correct answer. Now let us move with the next question, dear students. Here we have with the question number 7. So as I said you before, so that you have already learned that the electric field at an axis axial line and electric field at what we can say even at equatorial line, right, equatorial plane, those formulas we have already did. So that formula I am using here to calculate the ratio of x is to y. So let us go with the question first. If the magnitude of intensity of electric field at a distance x on axial line and at a distance y on the equatorial line on a given dipole are equal, then x is to y is, see what they given, the magnitude of intensity of electric field. That is what, the electric field intensity at a distance x on axial line and the magnitude of intensity of an electric field at a distance y on equatorial line of a given dipole, both are equal. First here let us come with the point that the axis, that is what, the magnitude of the electric field along an axis is equal to that of electric field along equatorial plane. But for along axis what they given, the distance what they given here, the distance is here what they given, the distance is x for axial line. So what is the formula for E? So you know that, my dear students, it is 1 by 4 pi epsilon naught into 2p divided by r cube. That is what I can write it as x cube, because in the question they given that it is x on the axial line. So I am just going to write it as x cube. Similarly, I am coming with the equatorial plane. So here for equatorial line for a dipole, that the electric field K can be written as P by x cube. That is what P divided by. Dear students, here in the question they given for an equatorial plane, here equatorial plane, y is the distance. So that I am just writing here it as y cube, right? So here what are the things which are going to cancel with each other? P and K. Remaining is 2 divided by x cube, which is equal to 1 divided by y cube. But we should calculate the ratio of x is to y. Then just by cross multiplying the terms, so x cube divided by y cube is equal to, x cube divided by y cube is equal to 2 divided by 1. Right. So ನಮಗೆ ಏನು ಬೇಕು, x is to y ಬೇಕಿತ್ತು. So x cube by y cube is equal to 2 divided by 1 we got. Then x by y, that is what I am applying cube root, it becomes cube root of 2 divided by 1, right? So x is to y. So I am just showing you x is to y is equal to cube root of 2 is to 1 is the right answer. So now let us move with the next numerical, that is question number 8. Yes. Here we have a charge q which is placed at the center of line joining two equal charges plus q, that is what capital Q each. The system of 3 charges will be in equilibrium if q is equal to. Here the question was like this. It means we have the 2 charges which are exactly equal, that is plus q, capital Q. So whereas these 2 charges which are exactly at the 2 ends, and for this charge we are going to place another one charge small q, whereas joining the 2 equal charges plus q. Now let us write the diagram first. See, we have the 2 charges, let us say capital Q. A charge q is placed at the center of line joining the 2 equal charges, right? So whereas the 2 charges are plus q, so at this point I am going to place another one charge, say it is q. The 3 charges will be in equilibrium. Yavaga ಈ 3 charges equal ಆಗಿರುತ್ತೆ? This was a question. My dear students, when these 3 charges will be in equilibrium, when the force acted by the charge plus q on the charge q and the force which was acted by the charge capital Q and the charge small q which is placed at the center, if I just do the sum of these 2 forces and I just equate it to 0, it comes the equilibrium position. Now let us calculate. Then our time al namge q ಏನಾಗಿರುತ್ತೆ ಅಂತ ನೋಡೋಣ. So my dear students, we know that the equilibrium is possible only when the force acting on the charge QQ plus the force acted on the charge small q by plus q is equal to 0. Then what is the formula? You know that k into q by, that is k into q1 q2 by r square. See my dear students, here I am just going to consider that the distance between the total this q and q is x, and this is considered as x by 2. That is what the distance between the capital Q and the small q is x by 2, and the distance between the capital Q and the capital Q is capital X. That is what the distance is, x. Now let us substitute it, my dear students. So I am just going to write it here. So I will just show you the distance also. The distance between these 2 charges is x, and the distance between the small q and the plus q is x by 2. Similarly, the distance between plus q and the minus q is x by 2. Then hope you are all listening here. So that the force formula is k into q1 is capital Q, q2 is capital 2, q divided by r square. That is what the distance between q and q is x, so that it becomes x square plus again k into Q1 Q2 by R square. What is Q1? It is capital Q. Q2 is small q divided by R square is x by 2 whole square. Now I am just doing which is equated to 0. Now just K Q into Q divided by x square plus K into Q small q. Your that is what your 2 square is in the denominator of a denominator, which comes to the numerator. That is what 4 divided by x square becomes equal to 0. Dear students, now the common terms in this is equal to, so I am just taking out the common terms here. So dot the common terms which was present here, you can observe K capital Q divided by x square is a common term into, you can observe that the remaining is capital Q and also the thing is plus 4 small q, which is equal to 0, right? So it means I can take this value to this side, which comes to 0. Then q plus 4q, which is equal to 0. Remaining that I want to calculate the value of q. So 4q is equal to minus capital Q, which is equal to small q is equal to minus q divided by 4. Dear students, you can observe that I got the value of small q, which is placed exactly at the center of the two charges, that is capital Q is equal to minus q by 4. That is which option is the right answer, my dear students? D. Option D is the right answer. That is what? Minus q divided by 4. Now let us move with the next question. So that here we are with the next question, that is what? Question number 10. So you can observe the question number 10. Here they given that a bullet of mass 2 gram. So you can observe that they given the mass is said to be 2 gram, right? I am just going to write the mass m is equal to 2 gram. Let us convert that 2 gram into kg. That is what 2 into 10 to the power of minus 3 kg. So I just written the mass, which is equal to 2 into 10 power minus 3 kg. Is moving with a speed of 10 meter per second. What is the velocity they given? V is equal to 10 meter per second. Whereas if the bullet has a charge of 2 microcoulomb, that is what is the charge of a bullet? That is what? 2 microcoulomb. Through what potential must it be accelerated starting from rest to acquire the same speed? That is what we should calculate the potential. See, my dear students, I am just going to represent the velocity by small v and the potential by capital V. So this is what the potential I am just going to calculate. So how to calculate the potential? Dear students, to calculate the potential, we have the formula. But rather than using of the formula, here just what they said, the bullet is just moving with a speed. It means according to work energy theorem. I am using work energy theorem, right? Work energy theorem. So work is equal to kinetic energy. What is work? Charge into potential capital V, which is equal to the kinetic energy can be written as of mv square. Then my dear students, I want to calculate V. Keep V as it is. So then remaining is mv square divided by 2 into small q. Now dear students, I want to calculate V, right? So that capital V is equal to what is the mass? 2 into 10 to the power of minus 3 into what is the velocity? 10 square divided by 2 into what is q? The q value is given that 2 microcoulomb, that is 2 into 10 to the power of minus 6. Now here 2 cancel with each other. Remaining is 1 by 2. 1 by 2 can be written as 0.5, right? Into 10 to the power of minus 3 plus 2 minus 6 we have. So it means totally we'll get, that is what? 10 to the power of minus 3, right? So it becomes plus 6. Yes. Plus 6 plus 2 is 8. 8 minus 3. 8 minus 3 is 10 power 5 we have. Then my dear students, here V can be written as 0.5 now. I can write it as 5 divided by 10 into 10 to the power of 5. Right? 110 cancel with each other. Remaining is 5 into 10 to the power of 4. But here in the option, it is not there 5 into 10 to the power of 4. So I am just going to convert that 5 into 10 to the power of 4 as, see that 5 into, into 10 into 10 to the power of 3. It means 5 into 10 is 50 into 10 power 3 is kilo volt. So I can say that V. So I am just writing it here. So that the potential V. So that the potential V, capital V, is equal to 50 kilovolts. See dear students, that is what the option D is the right answer. Okay dear students, today we have discussed almost all the 10 questions in this class. So hope you all learnt well. Thank you dear students.
ಚೆನ್ನಾಗಿ
Thank you, madam.